Awesome. Thanks, George. Ooh, I hit a button on my headset. Yeah, so for those of you that don't know me, my name is Mason Egger, and I'm going to be talking to you today about kind of new field that's coming out in the technology space known as durable execution and temporal, and what temporal offers in ways of durable execution. But first, come on. There we go. Hi, I'm Mason. If you don't know me, I'm a senior technical curriculum developer at Temporal. So I'm talking about, what I do for a living tonight. I am a programmer. I do a lot of all sorts of programming stuff. Python. I did security and SRE for a while. I was in SRE for a long time. I'm an author. I write tutorials, blog posts. I'm also working on a book right now that'll hopefully be out, by the end of the year. Depends on how quickly I write the book. I'm a PyTexas community organizer. I will talk more about that at the end of the presentation, and I'm a teacher. So today, we're going to talk about applications and how we got where we're at, and what I think the future holds for the development of modern applications. So we're going to review modern applications. We're going to talk about where we started, how we got here. I'm going to introduce you to Temporal, which is a durable execution framework. We're going to review an example temporal application. We're going to see it in action. We're going to play around with it a little bit, and we're going to watch it recover from a failure. So that's a high-level overview of where we're going today. So a brief history of application deployment. It's funny, interesting. Most of the stuff that happened, it was really interesting about application deployment, happened before I was in the industry, some of it before I was born. But monoliths was kind of how we originally deployed applications. We started off with mainframes, and all of the code was in a centralized location. We move into data centers and deploying applications, and it was very common for your database and all of the services to be running inside of a single process or inside of multiple processes on the same machine, but they were all co-located either within like a physical server on in a rack somewhere in a data center. About 10, 15, I don't know, so many years ago, we started talking about microservices. The 12-factor app was kind of the beginning of this. And splitting up these different functionalities of our applications into various components. We started down this road by, originally just taking our monolithic machine on physical bare metal, moving this into virtual machines, maybe having the database in virtual machine A and the application code in virtual machine B. As we progressed, we got things like containers, where we started splitting up more and more things. Maybe instead of running all the application code in one virtual machine, we run a single virtual machine with multiple containers, and each of the different microservices are now in these containers, but yeah, we're still running on virtual machines. Then we get into orchestration. This was the birth of really and truly Mesos and Marathon kind of started this thing, but Kubernetes is what most people are aware of. And there's also HashiCorp's Nomad. So we get into container orchestration, and then we get into serverless and edge computing, and it just keeps going. Like, there's probably something that happened today that I'm unaware about that's moved the way forward on how we deploy applications. But at the end of the day, like, where did this lead us? Like, we went from a monolith where everything was on a single box, where everything is separated now. And what this led to is that all of our modern apps are basically distributed systems. All the functionality is split across various microservices. They're almost exclusively accessed via the network in some way, shape, or form. And we have multiple instances of a single service, whereas instead of just having one large server that handled the front end connections from a website, now we may have multiple servers that handle, serving the homepage. We basically went from scaling vertically, which means adding more resources to hardware, to just scaling horizontally and having more smaller pieces and distributing the load across them. So I may ask you just real quick if you have any examples or anything, if you want to type them in the chat, or just kind of think it to yourself. What kind of things typically can go wrong in a distributed system? Like, what did we lose whenever we moved into this style? If anyone wants to type it into the chat, I'll give you a minute. If you want to unmute, feel free to come on and say hi. If not, I'll give it a few seconds, and then I'll just move forward. So think about it real quick. Like, what kind of things can go wrong in distributed systems? I/O problems. That's a great one, Jacob. Everything is also a correct answer. Everything can go wrong, but yeah, multiple points of failure. Yes. The network now became all sorts of issues. Transactional constraints broken, split brain, 100%. Yes, these are definitely some things that can go wrong in distributed systems. I have a list here of some of the things that I have written down, but those are also really great ones. External APIs can go down. Maybe maybe I have an e-commerce site and I rely on Stripe to process my credit card payments. If Stripe goes down, now my entire website is down because of this kind of thing. We have database could go offline or it could fail. Like we could have a catastrophic database error, which is always fun. If you've never been in one of those, I highly don't recommend it. Your queues can back up. A lot of modern applications are now using messaging queues, like such things as Kafka and RabbitMQ, to send messages and like trigger events and things. And if you're not managing these queues, these things can back up. Things can time out. Like we just, maybe I sent out a request, maybe someone, unplugged a server somewhere. Maybe someone messed up some routing tables on a core router, and now all of Google is routing to the other side of the world because somebody, messed up the BGP tables. If you don't know what BGP is, it's the most terrifying thing in the history of the internet. I'm not going to go too deep into it. I might do a lightning talk on why BGP is terrifying. It's the thing that keeps me up at night. But there's so many things that can go wrong in distributed systems. We also have just other challenges. Sharing state now becomes very difficult. Now, instead of being in a shared memory system, we have to shared state. Now we need another database to manage the state, or another table in the database at least. Being able to guarantee idempotent transactions. This is something that most people don't think about, but whenever I click, submit a button and I want to charge something, if there's a failure in a process and it charges me twice for the same item, I'm going to be really ticked off that I lost my money. So idempotency becomes a big thing in these problems. Managing long-running processes. This one's really difficult as well. Like, the longer the process runs, now again, we have to maintain state. So what if I have an application that I want to run for days, weeks, maybe even years? It gets really challenging. And basically what this has led to is that the more powerful the systems get, the more tools we have added to this toolbox, the more unhappy developers have become. Like, I remember when I was in college and I was writing my first website, and everything was on a single droplet on DigitalOcean, and life was so much more easy than instead of me having multiple servers with multiple microservices and having to do all the security rules for all that, and just not fun at all. So we've become less productive and less focused because of this. We have to spend all of our time focusing on handling errors rather than writing the code that actually matters. We have decreased our feature velocity because of this. We're not moving as quickly because, again, we're less focused. The systems have become less reliable. It's really funny, some of the most resilient systems that I've ever seen are giant monoliths running on a giant Dell server in a rack somewhere. It's not these things that are distributed across 4 different AZs. There's part of it's over here, part of it's over there. It's made life a lot less fun. And this is coming as someone who used to run an SRE PaaS for Expedia. I've seen the dark side of this. I don't ever want to go back. It's actually why I went to DevRel. I ran away screaming from SRE work. Also, you don't get paged in DevRel. That's the fun thing. And it's just difficult to get into invisibility. We now need there are now entire companies built around monitoring tools just because we've made our architecture so complex. Now, we do have tools to kind of fix this kind of stuff. We have implemented patterns. I've always said that whenever computer scientists don't know what to do, they will start creating patterns and pushing patterns on people that kind of make sense in theory, but rarely ever actually work in reality. So we have Saga, we have CQRS, we have batch processing, we have circuit breaker. But then what happens is that you have to implement them. And every new time you go to a project or you go to a new job, you wind up re-implementing the same thing all over again. You're constantly rewriting this error handling code. Now, what if I was to tell you there was an easier way? This is the most, I'm about to bring up the ShamWow. This is the most infomercial slide in the entire deck. But there's a new kind of programming model that is arising that makes a lot of this a lot easier. And this programming model is what we call durable execution. So durable execution is a new development abstraction that allows us to automatically maintain application state and recover from failure. So this can handle anything from small problems, such as a slight network timeout, to major issues like a server kernel panic, or maybe US East 1 goes down. This durable execution can persist and recover after these kind of failures. It ensures that your applications run reliably despite the adverse conditions that you may come up against it. It ensures that the reliable and correct execution of your code. And it improves developer productivity by making applications easier to develop, scale, and support. Durable execution provides a lot of native primitives that handle a lot of this error handling. So it decreases the amount of code required to handle various failure states, such as timeouts, for example. It provides built-in scalability and tooling for inspecting past and present workflow executions. And it allows the developer to focus on something they actually want to focus on, which is the cool work of the project. No one goes to work in the morning and says, you know what I really want to do? I want to import a back off and retry method for this microservice call. Nobody says that. And if you do, you have a place close to my heart, because I actually do find that stuff kind of fun. But most developers, and in reality, most businesses, want you to be focusing on the code that makes them money, and that code is making sure that whenever we click checkout, that the right item goes to the right, shipping label. Not, oh, now we have to back off and retry, and what do we do if US East 1 falls over? I'm going to make fun of US East 1 a lot. Haha, AWS. They have way more money than me, so I can make fun of them. Always punch up. So, durable execution is a programming model that is arising with this, and one of the leaders in the forefront, and I say that because I work there, haha, but really and truly it is Temporal. So Temporal is an open source programming model. For those of you curious, it's MIT open sourced. If you're unaware of what that means, it's the most permissive open source license in the world. It basically means here it is, don't blame me if it breaks. It's actually my favorite open source model is the BSD2 clause, but that's a completely different meetup talk about open source licensing models. I have a lot of very strong opinions on that, as does pretty much everybody. So Temporal is an open source programming model that can simplify your code, make your applications more reliable, and help you deliver more features faster. So a couple of the benefits of Temporal. Temporal gives you durable execution, meaning that your programs run successfully even if they face a failure. One of the things that makes this a little bit different than some of the other durable execution models that are out there is you write the code in your programming language. So I think one of the things that Temporal gets compared to often is something like Airflow or Dagster or Camunda. And a lot of these things are either DSL specific, so like you have to write in their thing, or you're writing some sort of YAML templating or something like that. Temporal is not like that. Temporal provides language specific SDKs to every single programming language. So you don't have to worry about writing those, weird YAML files. I hate YAML. That's lightning talk number 2, why me and YAML do not get along. Temporal's platform and SDKs abstract away the complexities about retries, rollbacks, queues, state machines, timers, all sorts of stuff. We're only going to cover like a little bit of it today. If I was to give this talk and talk about everything Temporal, we'd be here till tomorrow. You package and run your code like you always have in your environment. There's no changes to it. And the Temporal service provides a fault-tolerant durability layer so you can recover from failure. And people may be asking, oh, maybe I've heard of this, or maybe I haven't. Who uses this? A lot of big names use this product. If anyone's already familiar with this, with Temporal or anything, just a quick, it's a fork from a project called Cadence, which was developed at Uber, which is basically Uber's durable execution model. The founders, people who created Cadence, founded Temporal. Yes, we are a company, but again, the product is all MIT open source. You can run this on your own hardware and never see me again. I think that would be sad. I think you should come to PyTexas, but you don't have to give Temporal any money to use Temporal. It's 100% open source. So let's talk about the core components of Temporal as that relate to this talk. Again, there's so much stuff to Temporal. We're gonna get through as much as we can tonight, but I'm not gonna also try to overwhelm you. So the core components we're going to talk about tonight are workflows, activities, workers, task queues, and the cluster itself. And we're going to go in deeper into all of these real quick. So what is a workflow? Conceptually, and just think about this not in temporal terms, but think about this in programming terms. What is a workflow? Well, a workflow is just a definition of a sequence of steps that happen to perform an action, which is a business process. You can think of something like a bank transfer. A bank transfer is a great example of a workflow. I'm gonna send money to Jacob. What I do is I go online and it takes money out of my bank account. It does an online request. It sends money to Jacob's bank account. That's multiple steps. Now, maybe, yeah. I see Jacob over there giving me a thumbs up. He's waiting on the money. That's multiple steps, and each step is prone to failure. So we have to handle that. We have to know how to deal with that. Workflows can hold state. They must be deterministic. In Temporal, your code must be deterministic. Non-determinism causes a lot of really fun issues, which we will explore later. And then workflows can run and keep running for years, even if the underlying infrastructure fails. So you can start a workflow process, It gets scheduled on a worker. The machine that workflow is running on could be deleted as part of a accident. Oh, oops, I accidentally deleted an AZ. And all of the state where it was running will persist and come right back online. You probably never even noticed that it went down. That's one of the cool things about it. With Temporal, you can write your code workflows or you can define your workflows by writing code in your programming language. We currently support Go, Python, TypeScript, C#, and Java. There's also a PHP SDK, and there's a couple of unofficial community-based SDKs that other people in the community have started writing that may one day turn into official ones. But the main ones right now are these 5: Go, Python, TypeScript, .NET, not necessarily C#, but .NET and Java. So we have workflows, and then now what we have activities. So activities are normal functions or methods that execute a single well-defined action. You can think of it like you would normally think of a function. These can either be short-running or these can be long-running. Workflows are composed of activities. So workflow is the whole overarching thing. Say I have those 3 steps I have to send money to Jacob. We would implement all 3 of those as an individual activity, and you'll see why here in a minute. Activities are perfect for calling remote services and APIs, processing files, sending email messages. Any code that is prone to error or potentially non-deterministic is what you would put in a activity. Your activities also should always be idempotent. What this means, if you don't know what idempotent is, it's one of my favorite metaphors. It's pushing the button on the elevator. No matter how many times you push the button on the elevator is not going to get there any faster. So you can run a function as many times as you want. The state will not change because you've already executed that first time. So whether you execute it 1 time or 100 times, the state does not change. And then you write these in the programming language of your choice. And one of the interesting things about activities is when they fail, by default, they're automatically retried. So say I have an activity that's reaching out to the Stripe API, and the Stripe API goes down for 5 minutes. The activity will detect that it's down and just retry it. And then it will have an exponential back off and then eventually retry it again until eventually it comes back up. So you may see a delay in something being processed, but you have to write no code to make it where it automatically retries. Workflows help you build durable applications. So workflow code orchestrates the execution of activities, persisting the results. That's one of the key things we'll see here. So once an activity, so say an activity does something, maybe we have an activity that's computing some large number or something on a separate machine that needs a GPU. Once that result comes back, that result is stored in what's called our event history, which we'll talk about a little bit. So if the workflow were to crash, it would resume state and just use the last execution value. It would not re-execute the entire thing from start to finish. If an activity fails, I'm getting ahead of myself. I got a bullet ahead of myself. If the activity fails, the workflow runs the activity again by default. And if it crashes, Temporal automatically recreates its pre-failure state so it can continue right from where it left off. You'll find that I often jump around and get ahead of myself in my own slides. It's getting in the groove. Okay, so now there's also, within the concept of Temporal, there are task queues. Very similar to what you would expect a task queue to be. It's a lightweight, dynamically allocated queue for workflow tasks and activity tasks. So a task queue holds the tasks for the worker to perform. So a worker will pull the task queue constantly, saying, hey, do you have any work for me? Hey, do you have any work for me? Whenever work is sent to whenever an execution is requested from the Temporal cluster, it will be picked up by one of the workers and executed. Multiple workers can pull a single task queue. And what happens is clients request the execution. So like maybe I'm on my phone and I'm clicking, okay, order pizza. And I click that button, that would potentially hit a microservice that would call a Temporal client. And then workers in my data center would be constantly polling. They would pick up the task and execute it. Okay, am I getting ahead of myself again? I am. So let's talk a little bit about the workers. The workers listen to the task queues for the work to do. So they run your workflows and your activities. This is the most important part, and I probably should put this in bold. You run them on your own servers and with your own applications. So you are 100% in control of running your workers. Even if you're using maybe the Temporal Cloud product, which we will talk about very briefly, you run your own workers, and you could run your own cluster if you're self-hosting. You can run multiple workers to handle more load. So this is where the scaling part comes in. So typically, whenever you have to scale an application, in Kubernetes, you have to create new sets. I don't know Kubernetes as well as I used to, and all of that. And technically you still deploy temporal workers in Kubernetes, but whenever I want, so say I have 3 workers that are running and I get a sudden influx in pizza orders and my workers are falling behind, all I have to do is spin up another worker and say, run this like register it basically. And now it just automatically runs, and it's a horizontal scaling that requires no load balancing or really pretty much anything, because these are always pulling out. You might have to do some advanced stuff on your end for like orchestrating them, maybe in Kubernetes clusters, maybe in I can't even think. Virtual machines. That's where we went. Okay. I did see I have a question in the chat, and I might have missed this a minute ago. Yeah, it was 6 minutes ago, but I'll answer it anyway. Can you give an example of a multi-year workflow? 100%. So say I take out a mortgage and I have to make monthly payments on this mortgage for 30 years. And I only need the code to really execute once a month for 30 years. That's a long running workflow. Now, we may not think of these as long running workflows because the way that our software has been built in the past requires us to not really think about, oh, I can leave a process running for 30 years and it'd be okay. But in temporal and durable execution, that is totally the case. You can have a singular process managing these, what we call entity workflows, where a single person, like my mortgage, would be assigned to a workflow. That workflow would persist and be executing for 30 years. It gets descheduled when it's not running. And then whenever it becomes time, it basically turns itself back on, executes the code that it needs to, and then goes back to basically deregisters itself and goes back to sleep. It doesn't actually like sleep. Like the word, like we would be thinking sleep was like async.io.sleep or something like that, or time.sleep. It doesn't do that. It deregisters itself from the system, and whenever it's time for it to come back online, the temporal cluster lets it know, lets the workflow know. It gets a signal basically that says, "Hey, register yourself and come back online, do the work." Yes, that is exactly what I'm talking about. So I'm sorry to talk about the 5 parts. We're on almost the last part. 2 more. There's a lot of parts. The temporal cluster. So all applications talk to the temporal cluster. The cluster manages the execution of your workflows and activities using task queues. I need to delete one of those queues. It's kind of funny when you think about it. So basically it's kind of like the distributed systems term is typically called supervisor, but it's a little bit different in how temporal handles things. Basically what ends up happening is all of the event history, all of like what needs to happen is done in the cluster, and then the workers pull and bring it down. As your app completes tasks, events get added to the event history on the cluster, and then the cluster doesn't run your code. This is the big thing. So the temporal cluster is the thing. It's the brains of it. You can self-host it. We'll talk about it a little bit later, but temporal cloud is basically us hosting it for you, because it's actually kind of a pain in the butt to host, but the cluster itself doesn't run your code. So even if you use temporal cloud, your workers run on your infrastructure next to your data, and they stay there. Temporal never runs your workers for you. You are executing your own workers. I see we have a message in the chat. How would software be updated over the 30-year process? So there are something called versioning. It's a topic that I'm not going to get to tonight. It's actually going to be the topic of a new temporal course, which is what I do. I create free online learning references that are going to be coming out here in, I think, next couple of weeks. But there is a process called versioning, which allows you to basically pull a version of the code and have it running if it's running in that state. Or you can also spin up. You can direct temporal to spin up a new process, like a new workflow using a newer section, but like resume from this point in the history. It's a little bit trickier, but it is doable. So yeah, that's how you would update the process. But I mean, as long as your libraries aren't vulnerable, like you don't really have to do much with the update process. Imagine if you were just running all standard library stuff. Yeah, you might have some, workflows that are running, but as long as the Docker container persists, it would be there. So the last part is the temporal client. So the client is what talks to the temporal cluster. Each SDK provides its own client implementation. Workers connect to the cluster using the client, as well as the applications that you create also connect to the cluster to the client. So basically everything talks to the cluster via the client. Connections are outbound only, which is a really, really important thing. So the workers and your clients only ever dial in. Wait, no, that seems wrong. No, that's right. So yeah, they only ever dial out. So they dial out to where your temporal cloud is. Sorry, I got missed. It's late. I had a day. I had to do Java programming all day. Please, some sympathies. So your workers and your temporal clients only ever dial out. So you would be, if you have, again, like maybe you are hosting self-hosted somewhere else, or I'm just going to keep using the example of temporal cloud because it's easier. We don't have to say whitelist temporal to come into your IP address range. It would always just go out, so you never have to worry about inbound security requests from temporal. Okay, so that was a lot. Let's go ahead and talk about the code that you write. So all of that together, there's the code that you write, the worker configuration, which is how your code is run, the workflow definition, and the activity definitions. We call this the temporal application code. This is the code that you as the developer writes. We then have the temporal application, which all the other stuff that comes on top of it. The client is basically just a library. The temporal worker SDK, which is like basically an underlying state machine, is provided by the SDK, and that is the part that temporal writes that you use, but you never really dive super deep into this code, unless you have like a really good reason. But most of the time, I would say you don't. So that's what a temporal application looks like. If we look at the temporal cluster, we have a front-end service, a back-end service. We have an optional database, or sorry, the database is required. So you have a persistence layer, and then you have other optional services. You can have Elasticsearch, which allows you to have advanced like metrics and stuff. You also have something. You have Grafana, which allows you to do charts and all that kind of fun stuff. Sorry, Elasticsearch allows you to do advanced querying, not metrics. And then the database is your persistence layer, and we support multiple persistence layers. Then there's also just temporal cloud. So instead of running all that, I'll put that to us. So not really necessarily super here. Like we'll get up. Yeah, not going to talk too much about temporal cloud tonight. Cool. So basically how this works is your app makes requests to the cluster. So the temporal client makes a request to the front end cluster on the service across port 7233, and it gets responses from the temporal cluster, like, hey, you need a poll, or you need to add this thing to your event execution, to your event history. And that's how it works. And then the temporal worker basically relays that through the SDK and executes your code. Relatively straightforward way of doing it. So the durable execution pieces of this. Workflows are guaranteed to run to completion. So you start one, it's going to run to the end. As a workflow runs, it executes local code and activities. Workflows retry fail activities and only move forward upon success. Workflows then store the results of a successful activity's executions in the cluster's event history. In the instance of a crash, a workflow is rerun, and it rebuilds the state by replaying the history, and it doesn't re-execute things that had already completed successfully. So if I have a workflow with 10 steps and I fail on step 5, and it say it crashes and it rebuilds it from the event history, it's going to basically take the values that were stored in those other 4 steps, and it's going to reuse those and then continue on. And again, it's like you'll never even notice that it happened. Previous successful activities don't run again, and when the state is rebuilt, the workflow continues. Again, I just said that to myself. So here's the kind of more practical example. I apologize for the TypeScript. Okay, I couldn't find the slide to fix this. So basically, you have an HTTP request that comes in, say, from like a web form or something that goes to a web server, and then that server communicates across gRPC to the temporal cluster, and the temporal cluster communicates down to the temporal client. Okay, Alan has a question. What happens in an edge case that my code is not prepared to handle and will never complete successfully until my code is improved? Multiple things for that. So if you're running activities, you could potentially so by default, say I have an activity, I didn't handle the error, it will sit there and retry forever. It will eventually hit a back off policy. Like it has a default retry policy. It will eventually hit like the maximum amount that it can, exponential decay on the retries, and then stop on that and just go from there. Exponential back off, sorry. But what happens is you can also customize these kind of things. So if it's a known error, you can say, oh, this is what we call a non-retriable error. We know that this is an error, and we know we can't handle it. So just fail the whole thing. So you can fail the workflow. Like you can manually fail the workflow, and you can also just like complete stack trace and it explodes. Like that does happen. But if your code is correct, it will run to completion. But if your code is not prepared to handle something, if it's an activity, it will either just continue to run, and eventually you need to be monitoring to make sure, hey, something weird's going on, or you set it as like, oh, we know this error is not retriable. Fail the thing if we come across this error. So those are kind of the two options. The interesting thing, the thing that happens with temporal that a lot of people often forget because they're kind of used to using things like Airflow or Celery, is that temporal is all just code. It's all just Python code. how you handle your errors is really up to you. Like, you can program and do anything with it. A lot of people have gotten like stuck in the idea that, oh, I have to do it this way because this is what the tool like recommends. Temporal has a little bit of that, but it's much freer compared to almost any other durable execution framework that I have come across. There are other ones that are like only like there's like some that are for Rust, but only for Rust and stuff like that. Is there a notification system to notify operations when the final timeout happens? Ooh, that's a good question. I don't think so. I don't know if there is. I think that you would probably just implement that yourself. Probably you would probably, you would log an error and then send it across your own thing. You would see it. So like, is there like a message like, will it send a Slack message? I don't know. Would you see it inside of the Temporal web UI, which is a great place for like debugging and checking how things are running and stuff? Yes, you would see in there, and you'd be able to like query the workflow using certain things, and it would say, hey, final, like this failed with the final retry. I don't know if it would proactively send out a notification itself. You'd probably have to implement that. Cool. Awesome. So supported languages, we already talked about this: Go, Python, Java, TypeScript, .NET. You can even mix and match. So let's talk about an example application. Let's do hello world. Let's do a distributed hello world where things are really goofy. We're going to take in a name as an input as well as a language code. We're going to greet the user in the specified language. We're going to do Spanish because that's what was implemented. We're going to wait 30 seconds. We're going to say goodbye to the user in the specified language. And for simplicity, we're just going to like have this program only returned at the very end. But the twist is going to happen is that the program calls out to a microservice to perform these translations. So hello and goodbye will be two separate microservices hosted on two separate machines in two separate data centers. So real quick, what are some things that you would go ahead and type it in the chat, or on how would you kind of approach this? Like, what are some things you'd probably need to take into account in the instance that, say, I have this distributed hello world now? What are some of the errors that you think that we would run into, and what should we like prepare for? I'm gonna take a quick drink while everyone's typing. It's always so hot in my office. It's unfortunate. Okay, well, because I am running a little bit low on time, we're going to move forward. So here's a diagram of how we could do it. So we have a client that sends a message to a service, and the service is going to call the getGreeting API. That arrow is wrong. And basically what's going to happen is it's going to retry with the backoff. Then we have to, oh, there's a failure. Well, what do we do? Now we fail. Now we have to wait before and retry. On success, we return to the service, and we do the same thing for the call farewell API. So basically, we have to implement all of this failure handling code. In Temporal, it's really a lot simpler. We send a message to the Temporal workflow. It broadcasts a message to both of them, and then we just await the results. And when the results come back, we return it. So as you can see, we have greatly simplified our diagram here and our architectural diagram on how we have to do this. I forget what this exact particular. So I don't think is this UML? I think it's UML. I don't remember. I don't remember my diagram names. So let's talk about the application. We're going to have two activities in the application: translate hello and translate goodbye. We're going to call the workflow translation workflow. It's going to be a class. We're going to have a worker to host the workflows and the activities, and we're going to have a user interface to send the message. So this is the translate hello activity. We start off by importing AIO HTTP because this is going to be an asynchronous program and we have to perform safe URL requests. And we're going to import the temporal activity. We're going to create a class. In our class, we're going to create, we're just going to pass in an AIO HTTP client session. This is to prevent us from recreating a client session every time this is built. This isn't necessary for demo purposes, but it is good practice. We're going to create a translate hello it's a class method. And all we have to do to turn this method into a temporal activity is just decorate it with activity.defen, and boom, it's a temporal activity. We're going to specify the URL, greeting.egger.codes. And then what we're going to do is we're just going to submit an HTTP request. And we're going to say we're going to send it out with, all we're going to do is just get the translation, and we're going to concatenate the name together in the workflow. So we're going to get whatever hello in whatever language you want it to be. And then when we have the goodbye activity, it's basically the exact same code as above. In reality, we could have just, implemented this as a singular activity and passed in the URL. But for the sake of demos, I made it 2 separate activities. Same exact code, decorate with an activity definition, perform the HTTP request, return the translation. So the workflow is right here. So this, remember, we have activities, then we create a workflow out of our activities. We're going to, again, import some things. We're going to omit some imports for the sake of brevity. Temporal workflows are classes, so we have to define it as a class, adding a workflow definition. We specify a method. We don't have to call it run. I'm just lazy. And then you say, decorate your workflow with workflow.run. You would then say, hey, execute this activity method, translate activities dot translate hello. We're passing in the lang as the parameter, and then we have this start to close timeout, which is basically how long we're giving it to run before we consider it to be failed and try again. I'm not going to get into that tonight just because it's a little bit outside of the scope. We're going to then take the message and we're going to use f strings to concatenate it. We're going to make hello, and we're going to take the result and use the name. We're then going to sleep for 10 seconds, and then we're going to do the exact same thing, but for goodbye. So the same code that was right here, we're just going to change it to translate goodbye, and that actually really is the only thing that changes. And then we concatenate the 2 messages together, and we're good to go. So the worker then needs to be configured. The worker needs to know a task queue to poll and the workflows and activities it is allowed to perform. So whenever you configure a worker, they don't just automatically run every activity. You can say, oh no, this worker only runs this activity. One of the really cool features about Temporal is that it's polyglot, which means I can implement a workflow in Java and I can call an activity written in Python. And there's no extra code I have to do about it. We have this custom data layer that does all the translations for you. So you're like, oh, where's that useful? Well, maybe I have an application that needs to use like an AI or a machine learning model, and I need to train that model. I write the first bits of my code in Java, but whenever I actually want to train the model, I need to go off box. One, I need to use Python, and 2, I need to use an instance that is actually on a GPU. Like I don't need, my front end service doesn't need a GPU to accept requests, but my model training part does. So I can have that specific activity registered on a worker that only can get scheduled on a GPU instance, and it will ensure that it runs there. The workflows, so it is a task queue to pull, the activities to perform. The Temporal SDK provides the worker implementation. You build a program to configure it, and then the worker executes the workflow and activity code you wrote when it finds those tasks on the task queue. So it basically sits there and waits, and whenever it finds work to do, it executes it. So the worker configuration we have here, we have a handful of import statements to bring in all the things we need. We basically make a connection to the client. We're going to be doing this all on localhost, so it's going to be on my local machine. We're going to create a client, create that AIO or AIO HTTP client session that we're going to then pass in to the translate activities. And then we tell the worker, hey, you can run this workflow and you can run these activities. And since it's using this instance of the activities, that AIO HTTP client session will be in there. And then basically we just say, hey, run until, run, and then it just goes, and that's it. The last thing we have to talk about real quick is how do we start this workflow? So now we have a workflow, we have activities, we have a worker running, but nobody has triggered the execution of the workflow. You can start workflows with your Temporal CLI through the SDK using a Temporal client, or you can actually do it through a raw gRPC request, because all of this stuff just speaks gRPC. I don't recommend it, but some people are kind of wild. So whenever we want to start a Temporal workflow, we again do some imports. We can create a client to connect to it. And we basically say, hey, start this workflow. Here are the arguments that I'm going to send in. That should only be one argument. I forgot to update this slide. We're only going to send in it's hello in the language code, so I'm right. We're going to have the ID, which is translation task queue, and we're going to have the task queue name. So we're going to say on this task queue, request the execution of this workflow. We will then wait for the result and print the result. So we're going to start up our Temporal cluster. Temporal has a handful of multiple ways of doing this. There's a local single binary you can use for just running it locally on your machine, which is what we're going to do tonight. You can self-host using Docker, Kubernetes, all your own stuff. You can also use Temporal Cloud. You have to then start your workers, because you have to have the cluster running. You have to have the workers running, sitting there waiting to execute code, and then you start your workflow. So the flow of this will be the web app starts the workflow by scheduling it with the Temporal cluster. The worker will then poll for work. So the worker is continuously polling, and it's going to see that someone has requested execution. The worker will dequeue that task off of the queue. The worker starts executing the workflow, scheduling the activity tasks with the Temporal cluster. The worker will then continue to pull the temporal cluster for work to see if it finds any other activity tasks, and it will continue to dequeue these as it finds them. Once it's done and that workflow is complete, it is done. It will say it's complete. The web app will retrieve the result of the workflow execution, and the worker goes back to just sitting there listening, waiting for more work to run. Okay, that was a lot of talking. Let's do some demos. We're going to talk about workflows. We're going to talk about activities and all that. We kind of already went through the code. If there's any specific part of the code you'd like to see, please let me know in the chat, and I will pull up that specific part. But I think we're just going to move straight into the demo section. So, and I have to pull this up real quick and make sure that I have everything running the way I need it to. Okay, so this is all going to be done through the terminal. That's not the right button. That's not the right button. I messed up my terminals, like shortcuts. How do I view? Where's that zoom in button? Make text bigger. My command is not the command you think it is. I changed my command key on Mac, so it's probably cranky with me. Okay, hopefully that's big enough for everybody to see. Okay, so we're just going to kill that. We're going to kill that. Okay. By the way, I'm using a thing called Biobu. It's basically a screen wrapper, so it allows me to, I can change terminals. So what we're going to do is we're just going to start a local temporal dev cluster, and we're just going to ignore what that says, because there's a lot of stuff there, but really and truly it doesn't, like, I don't read most of the time what happens there unless something has gone terribly, terribly wrong. And then what we can do is we have a web UI. So this is one of the unsung heroes of Temporal. Is there's a web UI of our local cluster running. We'll be able to see workflows. We'll be able to see exactly what happened as we go through it. So now we go back to our terminal. I'm going to move that back right here. Come on. And we're going to start our worker. So in our code, we have the activities. We have shared.py, which is just some constants. We have a starter.py, which is what we'll use to start it. We have the worker, and we have the workflow. We're just going to run Python worker.py. And it's going to start the worker. And now if I come over here and I go Python starter.py, I'm not in the, I have to add, yep, you have to provide it the right things. That's how that works. There we go. Mason and ES for Spanish. So it's going to look like nothing's happening right here. If we go back over here, we're going to see some logging statements. So we've invoked the greeting activity. The greeting activity has returned hola. We are now sleeping between translation calls. We've invoked the goodbye activity, adios, and we come back over here and we see that it worked. Now that's nothing super special. Okay, let's look at some stuff here in the in the web UI. Oh, my alarm's going off, so I'm gonna have to pick up the trash. We'll do that later. So if we go back to the web UI, we can see every single thing that happened in this workflow execution. So we can see that we started the workflow tasks. We started the activity task. We provided the activity. Where's it at? Is it in scheduled? Yeah, we provided the activity with ES as our input. We received hola. We started a timer. This is a durable timer, by the way. We're going to talk about that in a second. The timer was then fired. We went and executed the activity again, and our result is right here. So these were the two inputs we had, and we had the result. So just alone, you already get all this kind of visibility in that you don't get with a lot of programs. But let's do something like this. Let's go back and let's run this again, but let's do German this time. Okay, so we've started, and now we're sleeping. Oh no, we killed it. It's gone, it's dead. Now, if you had a normal application that you ran hello, had a timer, and had said goodbye, what would happen if the program crashed in the middle of the timer, in the middle of the 10-second sleep? Does anyone want to put it in the chat? It's actually it's not a trick question, I promise. Yeah, well done, I guess. It basically means that you would start over. Like if you would like, okay, this process failed. I now need to start over. I guarantee you it's been more than 10 seconds, right? Like we've been talking, waiting on this for 10 seconds. Okay, all I have to do is go back and restart my worker, and there it goes. It has returned and automatically it completed. We completely killed the program. We brought it back online, and it automatically just worked. Now, what if I had something else? Oh, Mason, that's magic. Well, it's kind of really not. The greeting activity just did that. So we have it here where it just continued working. Now, what if I had like a really long timer? What if I had something that would say, like, let's say a minute? Let me reset the timer real quick. I can't. Where's my code? It's in the workflow, right? Yeah, it's in the workflow. I'm editing it in VS Code. So if we were to run that again, whenever you change your code, you have to restart it. We're going to say Mason for that, and let's go ahead and kill it. Okay, now it's going to take 60 seconds for it to happen. Again, what would probably happen if you had a durable timer that was happening is you would just, like normally, like you'd have to start over or something. But if I start the worker again, it's not going to do anything at this point in time, because what it's doing, the timer actually is persisted inside the temporal cluster. So say we had it, we started an application in 60 seconds, and at second 10 we killed it, but we were able to bring it back online at second 35. It will continue the remainder of that time and then execute. The timer does not restart. The timer is persisted across the event history. So if the timer would not have fired in the time between when the worker went down and went back up, it just resumes where it was. If the timer did go down in the time between the time like it went off, so like, we didn't recover this for like 3 days, it would immediately just resume. So as you can see there, it completed, and that just worked. So let's do that again. I'm going to do one. Let's see if I can root at greeting.egger.codes. I hope I added the right. I think I did. Good. Screen-R. Okay, so here is our translation microservice. So this is a fun one. So let's go ahead and, but I didn't want greeting. I wanted. Oh, I hope that didn't kill it. We'll find out. I wanted actually the goodbye. Egger.codes. Screen-R. Okay. So what I'm also going to do is I'm going to change this back to 10 seconds on this side, because I don't want to wait a whole minute while I'm demoing. Oh no, whenever I did that, wow, I messed up my Diobu somehow. That's weird. F2. This is okay. Anyway, so basically what I did is I killed one of the microservices. So the microservice is now dead. I cannot find what I'm looking for. That's what I'm looking for. Okay, so we start the worker, we start the result again, or we start doing. Oh, greeting's dead too. Huh, okay, I guess I accidentally killed both of them. Either way, it still proves the point I want to show. So the microservice is running, okay? And basically what it's telling me here is that, hey, we're on attempt number 5. This is the amount of time before the retries. It's actually sitting here consistently trying to retry and figure out, hey, what's going on? The microservice is down, but I'm not going to fail anything yet. Like we're something's wrong. And if you bring me back online, we will work. So I wish this was expanding a little bit better. Oh, there it is. I just have to scroll. So yeah, we can see the entire stack trace of what's happening. As always, here, good. Cannot connect to greeting. The stack trace is useless, but at least it tells me this is exactly what's wrong. So if I go back to my terminal, come on. Oh, that's there. And then we start the microservice again. Okay, so the microservice is running. We come back over here. We've made some progress. The error message is gone. That has worked because we brought the microservice back up. Temporal is durably executing. So basically that means we were just waiting for it to come back online. It came back online. We continue onward. You never would have known. This doesn't send out triggers. It doesn't alarm. I mean, it can alarm if you set it to alarm, but like that's not the point of it. The whole point of Temporal is we will pick up the crap and put it back together for you. Now it's probably going to fail again because I think I accidentally killed the greeting website. Yeah, I killed the greeting one too. This is what happens when you. This is what happens when you don't remember. Oh, I'm using my screen commands. My screen is killing my bio. I have nested screen sessions and it's killing the outer one, not the inner one. That's always fun. We'll just re-log into goodbye. Everyone watches me type, can't type. Cool. So now if I can just Python 3. Oh no, I have to activate the source vn bin activate Python 3 microservice.py. Okay, it's running again. Oh, and I didn't get to it before it finished. And again, the microservice came back online. We detected it. We completed the execution. Easy peasy. Let me check my slides and make sure there's nothing else. What else was in the thing to talk about? Yep, we did that, did that. Event history. So one of the things you can see here is we have all the events in the event history. They're stored with the data. Basically, each one has different things. The timer, where the timers work, this is where the data is stored. Like, oh, this was the message that we had. We can actually see, oh, this one actually took 7 attempts before it was successfully completed. So you actually have, and this data persists for as long as you want it to. So if you like, there is like a default retention policy, but you could go back and you can recheck what happened in these. You could even re-execute workflows that happened decades prior and just rerun it through this, and you'd be good to go. So you have all of this kind of like this history that keeps track of everything that happened, and your code basically, like, we couldn't really break it. Like, it was very difficult to break it. I guess, is there any one other thing that I want to? I guess there's one. I can show one more thing that's kind of cool to show. But I'm gonna have to. How do I get out of this now without killing my own? I think we're just gonna open up a new terminal window. I made a slight miscalculation in how my Bioba was gonna work. Okay, we're just gonna do. Yeah, I know you're angry. Shut up. So, oh, I could have done that. That's fine. So we're going to kill the worker.
Can I ask you a quick question about the stack?
Go right ahead.
So, what if you get something that doesn't produce a stack trace but crashes? Like, what if you get like a weird out of memory, or like some other silent errors are thrown where it just doesn't actually send a stack trace?
So basically what will happen is your activity will eventually time out, and it will basically like say on there, hey, this is timing out, we are retrying the activity. So if you have multiple workers, that's not
there.
There are heartbeats. That's another feature that I don't have time to cover tonight, unfortunately. But what I'm about to show is I'm about to show you a little bit of what we call how this is like super durable. So we have Python worker. And then what I'm also going to do over here, so now I have another worker. So I have Python worker. I'm going to run worker.py again. So I have 2 workers running now instead of 1. So if I go, I have to create another one of these. I do source vn bin activate. And then what I do is I do Python starter mason.that. Okay, so we find this one over here. This is the one that started with hello. Okay, I killed it now. So that service is gone. If we wait 10, where to go? Okay, so that was on worker number 1. On worker number 2, after 10 seconds, what's going to happen is that Temporal will detect that the worker that it was originally working on has failed. It will then recreate the entire state of that execution up to the point of failure on the other worker and continue execution seamlessly. No configuration on your part. You won't even know it happened. So we're probably going to see, I guess we're going to see that here in a second. If I did it right, I'm pretty sure I did it right. It already completed. Did I not kill the right worker? I didn't kill the right worker. I apologize. We'll do that one more time. Okay, worker, and let's execute it again. This is what happens when you dilly-dally. Are my services down again? It seems like stupid. It seems like these microservices are down. This is what happens when you have too many terminals. Makes life real. Okay, actually, let's just go to the web UI. If I can't debug the error, I can go to the web UI. Is there actually something failing, or did it just run so fast that it can't connect to greeting.egger.codes? Okay. Yeah, because I killed it here. You piece of junk. We're going to let that complete. Hey, this is what happens. Whenever you mess up in these, it actually works. What's the retry left on this? 14 seconds. Okay, we're waiting for 14 seconds. Okay, so it looks like both of my microservices are running. So we have these 2 right here. Both these workers are saying, hey, I can't figure out what's going on. I can't connect. One of them is eventually going to continue. There, that one continued. So what I'm going to do is I'm going to kill that one. So one of them completed. It's kind of hard to see, but it was like up here. I can't scroll right now. And what's going to happen is that one is dead. The second one, after the 10-second timer, is going to pick up where it left off and just complete the execution. This would have been better had there not been all this crap on the screen. If you want me to, there we go. There, yeah. So it finished the, Auf Wiedersehen. So it finished it, and there it happened. And why do I have so many terminals? And it executed. So if you have we always recommend having multiple workers running, because if one dies, the other one just picks it up. And in reality, what's actually happening on the background is the activities are not guaranteed to run on the same worker. Like I think like they can be, depending on worker load and all that, which Temporal kind of calculates on its own. They can go to completely separate instances. They do tend to try to prefer the one, because it has the state and it doesn't have to recreate the state, but it does, it can do that. The Java one is particularly picky about this. Yeah. Okay. I think I have like a few more slides. Does anyone have anything they want me to, any other questions or anything else they want me to demo real quick before I move on?
I have many questions, but I'll ask somewhat simple. So, what's the difference between this and something like Prefect or Airflow?
So yeah, those are some of the things that we often get compared to. So it has some, Temporal is more of a complete feature set. So a lot of things like Prefect or Airflow use like DAGs or their own configuration for this. All of Temporal stuff is written completely in code. So that's one of the big main benefits that people like, is because to engineers, it doesn't look any different. You don't have to go to some like special how to write the right YAML for this thing. But they are similar to that. Cadence, Airflow, Camunda, these are things that are very often compared to us. Where we shine is like on the SDK features, and I think there's just like a few more like advanced features that we offer that they don't offer. Fun anecdote about Airflow. Airflow was created by Airbnb to solve the exact same problem that Temporal does. Airbnb has migrated off of Airflow onto Temporal. So
okay,
take that as you will.
Good to know. One more question. You said you support many languages. Can it work in Python 2.7?
No, we do not support Python 2.7. This was written exclusively for Python, I believe 3.7 and higher. We can always ask, but I doubt they would do it. So the Temporal Python SDK I don't even think it's really a year old yet. Like, it came out in the time that I've been at Temporal, so it natively wouldn't have it. If anyone's really interested in how like the Python SDK works on the underside, there's actually a Rust core that Python calls into using PyO3. And then our .NET, our TypeScript, and our Python SDKs, and any future SDKs are all calling into this Rust core thing, which is what communicates with Temporal. And then our Go and our Java ones are different because they were the first ones there, and that's just how they are. But it's actually like the Python SDK is like a really large PyO3 project. So if you're curious in writing Rust extensions, it's a good piece of code to look at. Cool. Any other questions? I'm going to blaze through these last few slides real quick. Yeah, go ahead, Mike. You have your hand up. You might want to unmute. I cannot hear you. Oh, there you are. Hey.
Hi. I got a question. What's the difference between, or what's the main difference between Airflow and Spark?
Isn't Spark batch processing mostly? Like, and Airflow is more like orchestration of like AI models. I'm not very familiar with either. I dealt with Spark a little bit. I believe Spark is mostly batch processing, though.
Okay, thanks.
Yeah. Am I right about that, George?
Yeah. Spark is more for like batch processing of like data frames, is what I've seen it used for. And I've used it for. And Airflow is more for orchestration, as you've said.
Yeah.
Do you mean PySpark?
Maybe, and there's actually I think
it's Apache. I think is the same thing.
Yeah, I think it's like a Apache project, isn't it?
Yes.
Yeah. So all of those are Apache tools. PySpark is mostly for like querying data. Airflow is the orchestration one.
Yeah, and you can use Temporal for all your orchestration needs. Like that's what a lot of people are using it for. I think. There are big companies that I cannot name, and I cannot because we're being recorded, that are using it for orchestrating their AI ML pipelines. When the recording button goes off, I might cough and you might hear something, but I can't say it out loud. So anyway, I'm going to move on real quick to these last few slides. We're going to talk about just another quick example. Where's my slides? There it is. Another quick example. Let's talk about an email drip campaign real quick. So like say you wanted to send a specific series of emails to a customer. The customer can subscribe or unsubscribe, and they're going to get a certain amount of emails throughout the thing. Like, so they're going to get an email when they subscribe. They're going to get an email every month until they unsubscribe. The subscribed customer, 1 week from the drip campaign. Typically how you would do this is you would kind of use a job scheduler. The user would like request something across the server. They would save the details to the database. There's a job scheduler that's constantly checking to see if somebody is within the time frame to send the thing. It sends it out. You do this for each user. It goes to the email service. It updates the email status back in the database. It's a lot of moving parts for that. With Temporal, it's actually a lot simpler. You create a user subscription workflow. Each user is associated with a workflow, and then what happens is just a loop that goes through, pulls the database out, like for every X so many times in the week or whatever, however you want to implement that. Pull the database out, send it out, and then whenever the user cancels, send a signal to cancel it, unsubscribe them, and they're done. This is how you would kind of do it, like using a single subscription, but like this is what is known as an entity workflow. So you can map an entity to a workflow execution. A customer subscribes, they create a workflow execution tied to their email. The workflow lives that workflow lives the entire life of their subscription. It sends the email, then it goes to sleep, and it waits. Actually, that's what it would do. It would be in a loop and it would sleep. Sorry, it's 8:18 at night. The fact that I'm still speaking English is nothing short of a miracle. So it sleeps, comes back alive, does it. Whenever the user unsubscribes, they get taken out. The workflow is closed and it's done. The workflow can run for days, weeks, even years. Now, we talked a lot about building Temporal. How do you really go to production? The big thing to talk about with Temporal is that Temporal does not run your code. You deploy your Temporal application any other way. It runs in your data center, on your servers, the way you want it to. You scale your workers to meet the needs of your customers. You just add more workers and you scale horizontally. And then you ensure that your network can make outbound connections over TCP 7233. This would obviously be in an onboarding document. This is kind of an example of how it would work. You have your application. They're all sending requests out to a load balancer. There's some front-end service integrations. There's the history service, matching service, worker service. There are a lot of microservices that run underneath the hood of the Temporal cluster to keep things running. It probably looks something more like this. You would scale up as you need to. If you need more matching services, you would have to scale these up. History services. This is where when I said that this can get complex really quick, this is where it gets complex really quick. Like, as knowing when to scale each of these up. You don't really have the the expertise in like how Temporal runs, or maybe you do. This is my one plug of the night. If you don't want to run all that stuff and you're a business, you can run Temporal Cloud. Eventually, we're working on like self sign up. There's eventually going to be like probably going to be some developer tiers or stuff that's coming. We're an early stage startup, so right now the local binary, the single binary that you run, that's probably your best bet for now. I even use it to run, as long as it's not production level stuff, you don't have to really worry about it. You can use the single binary with a SQLite database, and that will get you pretty far for side projects. I do not recommend running that in production. Please, for the love of God, do not do that. The data, as those of you who have been thinking about how this might be working on the back end, the database is the most important part. Like maintaining that database. If you lose that database, things are going to go bad real fast. And that's kind of where Temporal Cloud's expertise come in. We have custom persistence layers that we've created, and we're experts at running this stuff. Quick summary: you can use Temporal workflows to orchestrate your code and ensure durable execution. Temporal SDKs let you write workflows and activities in your own languages, unlike many other workflow-based engines. You host your workflows, activities, and your workers. They run on your infrastructure, not mine. You use a client to tell the cluster to start the workflow execution. The workers poll the cluster for tasks, execute your workflows and activities, and store the results in the event history. Workers can use event history to rebuild the state of your workflows in the event of a crash. And you can run your own Temporal cluster or use Temporal Cloud. But either way, you run your code your own way. If you're interested and you want to learn more, there's docs and there's learn.temporal.io. We have a bunch of free courses and we're delivering more. So these are online free courses. You go, you plug in your email, you get to take my free courses. There's 101 and 102 in Python, which is about 8 hours worth of coursework. And we dive so much deeper into all of this. You'll actually get like walkthroughs on how the history workflow works. It's really cool. I personally did the Java and the Python ones for 101 and 102. So if you take those, you'll be seeing and hearing from me again. And we have like 4 or 5 more courses that are scheduled to come out this year alone. So there's going to be a lot of that. I think there was one more question in the chat. Is this intended to be used to track application state instead of an RD BMS? Yes, it can be used that way. Basically, it can remove the necessity for that. And that's kind of one of the really cool things about it. Like, I remember when I was first interviewing here and I was reading the docs, and I remember telling myself, if this product does half the things they claim it does, it's a huge step forward. And it's amazing. And it does everything that we claim it does. It's really cool. And like, it's open source. It's MIT. Like I said, you don't have to pay me a penny. You never have to give me a credit card. Now, my salespeople would prefer that you give us lots of credit cards, because that's how you get paid, right? You just put down multiple credit cards. I don't know. These are the jokes. If you don't like them, you came to the wrong comedy club. But yeah, this is all can be run on your own. There are many people that successfully run Temporal self-hosted. You're going to need a full-time team to manage it. It's honestly, and the Temporal Cloud is pretty well priced. You're going to pay more money staffing an engineering team of 10 engineers to run this than you would. So, but yeah, go learn it, build your side projects with it. I can't wait to see what you build. That's all I have. Does anyone have any specific slides or any specific questions or anything else they want me to talk about tonight? I can pull up code. I can talk about other things. I can tell terrible jokes. I'm good at all things. Doesn't sound like it. I hope you're all amazed and not tired.
It's definitely very nice. We do like a Kubernetes cluster, and it's all managed by DevOps guys. So this looks a little like easier to tackle as a single person, which is great.
Yep. Last thing, PyTexas, come to PyTexas. It's a fun conference. We will be April 19th through the 21st. I will drop the link in the chat again for anyone who wants to come and hang out. We're gonna have some really cool speakers. Gonna have some awesome networking opportunities. Definitely. And I'm finding that in today's market, networking is like one of the easiest ways to get a job now. So I highly recommend that you all network with as many people as you can.